Good morning to all who joined this presentation at the UV Days 2021, hosted from IST Metz. Even in times when personal contacts are minimized and travel is hardly possible, developments and innovations are driven forward. I want to introduce one of these innovations to you today. My name is Axel Becker, and I'm working in the Technical Marketing Group at BASF, responsible for the resins used in UV and EB curable formulations. Today I would like to introduce you to a UV curing process with a UV lamp that has been newly developed by IST, which can lead to a waiver of photoinitiators. New curing methods that help to avoid critical paint components or to keep the proportion of these components as low as possible are an important contribution on the sustainability of coatings. The new developed lamp from IST opens the possibility to cure UV coatings and inks in the future without initiator and helps to reduce the related problems in the applications. IST uses lamps with a high proportion of emissions in the UVC wavelength range. So far, the main application has been sterilization processes and excimer applications. In the health sector, it has been possible to develop devices that use intensive UV radiation to prevent pathogens from dividing. The UV light used blocks the DNA, and viruses and bacteria are no longer able to divide and are therefore inactive. Wavelengths of 172 nanometer are used for UV matting. Here, the hardening of a very thin layer on the coating surface leads to a folding process, which makes it possible to produce dull, matte UV coatings. However, curing with these excimer lamps can only be carried out in an inert environment, since the radiation in the presence of oxygen is converted directly into ozone and can't no longer used for matting the coating. With the new UVC Plus lamp, wavelengths are now used for curing that do not lead to a matting of the coating surface, but effectively convert the double bonds in the complete polymer. The complete waiver of an initiator in the clear coats and curing in the ambient atmosphere is another advantage of this process. There is no need for inert gas such as nitrogen. What is behind this new UVC Plus lamp? Curing without nitrogen as an inert gas and waiving photoinitiators naturally entails development efforts. IST had to develop a new UV device that made it possible to effectively convert the double bonds present in the polymer. Oxygen inhibition and ozone formation in a non-inert atmosphere also had to be taken into account. For this purpose, the following device parameters were worked on. The electronical control has been optimized, adaptation of reflectors on the new requirements, and adaptation of glass qualities used for lamp production with a particularly high transparency in the related wavelength error where necessary. Before we deal with the curing results, I would like to briefly address the two most important hurdles in the development of the UVC Plus lamp. As already mentioned, UV curing processes are always subject to inhibition in oxygen atmosphere. This oxygen inhibition can mainly be seen on the paint surface. But that's exactly where extreme properties should be achieved, especially in the furniture sector, and insufficient curing is not acceptable. Free radicals, formed by the stimulation of photoinitiators, are intercepted by oxygen, and these are then no longer available for the actual curing process. Sufficient reactivity can usually only be readjusted via modified binders or the amount of initiator in use. The hardening chamber processes under inert conditions lead also to improved surface hardening. However, an increased amount of photoinitiator can in turn lead to problems with migratable constituents from the paint. Unreacted initiators and their cleavage products can lead to further problems, for example, yellowing and unpleasant smell of the painted surfaces. This is precisely what should be avoided, since regulatory requirements are very strict, especially in packaging printing, and prohibit excessive emissions from the coating in order to protect consumers. Many new regulations concerning initiators and their cleavage products now address this issue, and lead to a critical examination of the corresponding coatings. The UVC plus curing process can provide a remedy here and open up new possibilities for effective UV curing without migration problems of initiators and their cleavage products. In order to consider the suitability of the UVC plus curing process for coating and printing application, both 100% UV resins and aqueous UV binders were used. When formulating the aqueous and 100% paints and printing inks, the following aspects were taken into account: the chemical composition of the binder, the functionality of the binder, amine modifications to effectively suppress oxygen inhibition, and the physical surface drying of aqueous UV dispersions. The tests already show that these new lamps show good properties with 100% UV resins, especially in the printing and packaging area. High double bond conversions are achieved here using epoxy and urethane acrylates. The use of amine-modified binders to suppress oxygen inhibition also has a positive effect on the hardening properties achieved. Aqueous UV binders can be used effectively in the furniture sector in particular. Of course, it also applies here that before curing with the UVC lamp, the water must be first removed from the coatings in the drying step. After drying, a high degree of physical drying ensures that the UV dispersions effectively suppress the oxygen inhibition, which is very pronounced with 100% resins. This has a beneficial effect on the achieved hardening properties. After UVC plus curing, the double bond conversion, chemical resistance and scratch resistance are on the level of the standard curing tests, including photoinitiators in the formulation. Next, I would like to show some results where we compared binders from the 100% and the waterborne monomer range. Let us start with the results from the 100% resins. Here we carried out a screening and I have shown the results in the diagram above. The alcohol resistance of the cured film, determined by double strokes with a cotton ball, was shown against the double bond conversion determined with Raman spectroscopy. The curing took place with the new UVC plus lamp at 30 meter per minute with a lamp power of 200 watt per centimeter. It can be seen here that the amine-modified binders and mixtures out of these two POAs, epoxy acrylates or high-functional urethane acrylates, already give good double bond conversion rates and solvent resistances. In the diagram below, the power of the lamp was increased to 300 watt per centimeter and the curing speed has been decreased down to 15 meter per minute. Mixtures of epoxy acrylates and amine-modified polyethers and correspondingly modified urethane acrylates then already show significantly increased double bond conversion rates, which are known to be on the range of results obtained from standard hardening processes. Next in the comparison are the aqueous UV binders. In the upper diagram, you can see a comparison of the double bond conversion of two UV dispersions. UV-PUD1 is a selling product with a little bit lower physical drying. UV-PUD2 is a development product with a little bit higher surface drying. The dispersions were cured with a standard medium pressure mercury lamp with and without photoinitiator. On the far right in the diagram, you can see the corresponding curing with the new UVC plus lamp without photoinitiator. The double bond conversion of the UVC plus lamp is on the same level as that of the medium pressure mercury lamp, but without using any photoinitiator. In the second diagram, I have applied the results of a scratch test with a Scotch-Brite SUFM fleece. Here, the gloss of the surface described above was before and after scratch load, measured in 60-degree angle. Here too, you can see that the UVC plus curing here in the background, without photoinitiator, is on a comparable level with the standard mercury lamp in the front. If you now harden the paints without a photoinitiator, the standard lamp achieves significantly poorer scratch resistance. You can see it in the middle. In summary, I would rate the curing tests with the UVC plus lamp in the aqueous and 100% UV lacquer area as very positive. The hardening results are in the double bond conversion, the scratch resistance, and the chemical resistance, with the hardening of a standard mercury lamp with the use of photoinitiator comparable. We are working on results covering pigmented coatings. Here, the first results are promising in terms of surface curing and resistances. Pigmented lacquers can be effectively cured in thicker layers, as is usual in the furniture sector, with the use of an LED lamp. In the case of additional curing with LED, however, a depth initiator should be used. This guarantees effective curing in deeper layers in pigmented coatings. I don't want to miss giving you a starting recipe for the corresponding results. These are rough guideline formulations, but they should be sufficient for the first attempts with this new UVC Plus lamp. If you have further questions about the range of binders from BASF or application-related questions in connection with your applications, I'm available for you at any time. I would like to thank you for your attention, and I wish you every success in your experiments and, what is even more important, good health to you and your family. Until next time.